For almost all of human history, our whole picture of the cosmos came from what we could see with our own two eyes. But over the last few centuries, science has given us these completely new ways to perceive the universe, opening windows we never even knew were there. So let's dive in and see how these new perspectives have completely changed everything we thought we knew.
So this is the big question, right? This is what we're digging into. We're about to go on a journey from, just looking up at the stars to literally listening to the fabric of space-time itself. And the first step, really, was just realizing that what we see isn't the whole story. Our senses give us a beautiful, sure, but also a fundamentally incomplete picture of what's actually out there.
So get this. The first new window wasn't some new technology. It was an idea. Back in 1725, an astronomer named James Bradley was just trying to measure how far away the stars were. But in the process, he stumbled onto something way more profound about our own place in the cosmos.
He discovered something called the aberration of light. And this is where it gets kind of wild. It's not the star that's wobbling around, it's us. The simple fact that our planet is hurtling through space actually changes how we perceive the light coming from distant stars. Okay, so take a look at this. It's a great way to picture what's happening. If the Earth were just sitting still, you'd point your telescope straight up at a star. Simple enough. But because we're moving, you have to tilt your telescope just a little bit forward to catch the light as it comes down. And this is just the perfect analogy. I mean, think about it. You're standing still in the rain, no wind, the umbrella is straight up. But the second you start walking, what do? You tilt it forward. It's the exact same principle with starlight hitting our moving planet. Just a simple, brilliant analogy for a totally universe-altering idea. All right, let's move on to our next window, which, believe it or not, was opened completely by accident. We're talking about the height of the Cold War, when the US launched satellites for a very specific, very earthly reason, but they ended up finding something truly cosmic. So the mission was pretty straightforward. Use these Vela satellites to police the nuclear test ban treaty. They were just looking for the telltale flashes of gamma rays from secret nuclear tests. And the good news? They never found any treaty violations. But the amazing news, they kept picking up these unbelievably powerful bursts of gamma rays that were coming from way, way out in deep space. Yeah, these weren't nukes. They were gamma ray bursts, or GRBs. And we are talking about the most powerful explosions in the universe, second only to the Big Bang. I mean, they release more energy in just a few seconds than a billion suns. We were suddenly seeing a much more violent, high-energy universe than we ever imagined.
Now, for decades, nobody knew where these things were coming from. Were they in our own galaxy? Were they super far away? The big breakthrough finally came when they spotted the afterglow of a burst, sort of like the cooling embers of a fire, but in X-rays. And that allowed us to finally pinpoint them and prove that these cataclysms were happening in galaxies billions of light years away. Okay, so we've learned to see past our own motion, and we stumbled on the universe's biggest fireworks. But what about the quiet stuff, the hidden events? Well, our next window lets us peer right through these thick clouds of cosmic dust to watch stars being born. They're called Herbig-Haro objects, and you can really think of them as cosmic birth announcements. They're these super fast jets of gas being blasted out by brand new stars. And when those jets slam into the gas and dust around them, they light up. And this is why it's a whole new window. Just look at this. On the left, in normal, visible light, all you see is a dark, kind of boring patch of dust. Nothing to see here. But then you switch to an infrared view, and boom! The dust basically becomes transparent, and you can see the baby star and its incredible jet hidden deep inside. We're literally seeing what was completely invisible before. This also showed us that the universe is anything but static. So the Hubble Space Telescope took this amazing picture of one of these jets back in 1995. And now, look at this image from just 5 years later. You can actually see that the jet has moved outwards. We're not talking about geological time here. This is cosmic change happening on a timescale we can actually watch. We are watching a star being born right before our eyes. It's incredible. So, we've opened new windows using light and new perspectives. We figured out our own motion, and we accidentally found high-energy radiation. But this next step, this was the result of a deliberate 100-year-long quest. And it wasn't about seeing at all. It was about listening. It was about developing a completely new sense to perceive the universe. About 100 years ago, Albert Einstein himself predicted that huge accelerating objects would create ripples in the very fabric of space-time, what we call gravitational waves. But he did the math, and he figured they'd be so unbelievably faint that he was convinced we could never, ever build an instrument sensitive enough to detect them. Well, challenge accepted. This is LIGO, the Laser Interferometer Gravitational Wave Observatory. And it is, without a doubt, one of the most precise instruments humanity has ever built. It uses lasers fired down these 4-kilometer-long tunnels to measure a stretch in space-time thousands of times smaller than the nucleus of a single atom. I mean, it's just a monumental feat of engineering. And on September 14th, 2015, it happened. It worked. This is the signal they recorded. That little chirp you see, that is the sound of two black holes 1.3 billion light-years away from us, spiraling into each other and merging into one. For the first time ever, humanity had heard the universe. And if you want to get a sense of the sheer, raw power of that event, get this. In the final fraction of a second of that merger, the energy equivalent of 3 entire suns was converted into pure gravitational waves. It's a level of power that's almost impossible to even wrap your head around. So yeah, we have come a very long way, from just standing on Earth and looking up to building these incredible instruments that have given us a whole suite of new senses. We didn't just open one new window, we basically built a whole room full of them. Think about the journey we just took. We gained a totally new perspective with the aberration of light. We discovered a universe of unimaginable energy with gamma-ray bursts. We learned how to see with a new kind of light with infrared astronomy. And finally, we developed a completely new sense to literally hear the ripples of space-time with gravitational waves. Each one of these discoveries just fundamentally changed our place in the cosmos. It really makes you wonder, as we keep pushing, as we keep innovating, what incredible, unimaginable new sense are we going to unlock next?